Hey everyone, go ahead and open your books to page 71. We are starting lesson 5.2 called Domain and Range. So what that means is we are going to look at a function and be able to describe the domain and range. Then we will find input-output pairs for a function, also called x and y ordered pairs. All right, in the My Notes section of your book, I would like you to write down the words domain and range. Domain refers to our inputs, which is also our x values. So range would be the opposite. Range would be our output and our y values. So your book says that. It says the set of all inputs for a function is known as the domain, and the set of all outputs for a function is known as the range. So we have another vending machine, but this time, if you insert 25 cents into the machine, it dispenses 1 pencil. If you insert 50 cents, it dispenses 2 pencils, and so forth, up to and including all 10 pencils in the vending machine. So maybe our school should get one of these. So what we're going to do is we're going to identify the domain and the range, and I'm going to help you with this a little bit, but then I want you to pause the video and finish it on your own. Okay? When we write domain and range, we use the fancy brackets because that means a set. Now, if I don't need a pencil, if I come prepared, I don't have to put any money into the machine. Our domain, remember, is our input. What are we putting in? Money, quarters. So, if I don't need any pencils, I don't have to put in any money. If I need 1 pencil, I have to put in 25 cents. Then I need to put in 50 cents for 2 pencils, 75 cents for 3 pencils. So I want you to pause and keep going until you get your maximum amount of money, and you have to figure out what that is for 10 pencils. Go ahead and try it. So we can put in $1, $1.25, $1.50, $2. So if we put in $2, how many pencils are we going to get? We're going to get 8, so there's still 2 more pencils in there. So we can put $2.25 and $2.50, and then I need to end this set, this domain, with a fancy bracket. So our range, remember, is another word for output. So what we get out of this vending machine. So if I don't put any money in, I'm not going to get any pencils. So 0, 1 pencil, 2 pencils, 3 pencils, keep going. The maximum is 10, so we're going to stop at 10. Question 2, for each function below, identify the domain and range. Remember, domain, input, x values. So I want you to start with your fancy brackets. My domain is x, or input, So I'm looking, I have 7, 3, and 5. And it doesn't matter to me what order you put these in. If you want to write it in numerical order, smallest to greatest, 3, 5, 7, that's fine. Your range, remember, is your y values or your outputs. So fancy bracket. We get 6, -2, and 1. I really want you to try B, C, and D. Okay, for question C, if it helps you on your graph, you can write these out as an order of pairs. So this, I go over to 2, up to 4, and then I would need to say which one's my X, my input, my domain, which one's my Y, my output, my range. Okay, this point right here is over to 3, up 1. This point right here is over to 5, up to 3. So see if that helps you. Pause the video, work on domain and range for B, C, and D. So question B, 2, 6, and 8. Those are my domain values, my inputs, my X's. My range, my output, 4, -3. Yes, there are 2 arrows going to 4, but I don't have to write it twice. It's already accounted for once. Question C, my domain, all of my X values. So look horizontally from left to right. Or in your ordered pairs, it's your first number, your X coordinate. So I see a point at 2, 3, and 5. And remember, if you wrote it in a different order, that's okay. For my range, you're going to look vertically up and down. So I see 1, 3, and 4, my Y values, the second number in your ordered pair. Okay? Letter D. Remember, X, Y, X, Y. Domain is X, range is Y, input, output. So my domain is -7, 9, and -6. Your range, 0, -3, and 2.5. Question 3. Consider a machine that exchanges quarters for dollar bills. Inserting $1 bill returns 4 quarters, and you may insert up to 5 $1 bills at a time. So let's draw a visual, and let's talk about this to help us. So imagine when you go out to the arcade, you put in a dollar bill to get out quarters or tokens to play the machine. So that's what's happening here. So if I have a machine, and I have a slot right here, and what I put into this slot is dollar bills. $1 bills. And I can only insert up to 5 of them. Okay, and then what I receive out is your quarters. 25 cents, right? Your quarters. Okay. So our inputs here, my domain values, are your dollar bills. Your outputs, your range values, are the number of quarters. So I really, really, really would like you to pause this video and try your best on A, B, C, D, E, and F. It's okay if you don't know. It's okay if you struggle, but I want you to at least try it before I go over the answers. query says, is 7 a possible input for the relation that this change machine represents? So is 7 a possible input? Remember, inputs here are $1 bills. So this would be no, because we can't input more than 5 $1 bills at a time. So the maximum input is 5, so that means we can't put 7. Could 3.5 be included in the domain? Domain is input, which is dollar bills. Can I put 3.5 $3.5 bills? No. We can only insert whole number of $1 bills. Or you could say 0.5 doesn't work. Half a dollar can't be inserted. We're only looking at integers. C, what values are not included in the domain? Remember, the domain is input, which is $1 bills, and we can only insert up to 5. So instead of listing all the numbers that are not in the domain, let's write it out like this. Any values or any numbers other than what can we put into the machine? Well, if we don't have any dollar bills or we don't want any quarters, we can just put in 0, $1, $2, $3, $4, $5. So any values other than these are not included in the domain, in our input values. Because we can only enter a whole number and then no more than 5 at a time. So it would take a long time to write all of our negative numbers, all of our decimals, fractions, all numbers greater than 6, etc. Okay. Question D. Is 8 a possible output? Could I receive 8 quarters? Yes. Because if we insert $2, that equals 8 quarters. So if we insert 2 $1 bills, we receive 8 quarters, so that works. Could 3 be included in the range? Remember, range is another word for output. What do we get out of the machine? We get out quarters. Can we get out 3 quarters? No. That would be 75 cents. It would be shortchanged. What values are not in the range? Again, there are a lot of them. So let's say any values or any numbers other than, so if I put in $0, how many quarters do I get back? 0. If I put in $1, how many quarters do we get? 4. $2, we get 8 quarters. 12 quarters. 16 quarters. And lastly, 20 quarters. So any values other than these numbers are not in your range, are not an output. Right? Multiples of 4. And we had to stop at 20 because that's $5. Okay? Question 7. Oh, sorry, I skipped a page. Question 4. We're actually skipping question 4 on the top of page 73. So we're going to jump to question 5 on 73. Sometimes we can use machine diagrams. Okay, so this looks like an input-output like function machine here. And what we plug in is our x values, and we're going to put them right in next to the 2, multiply them by 2, and then add 5. And what we get out would be our outputs or our y values. So letter A says, what is the output if the input is x equals 7? So what that means is we're going to take this 7 and we're going to substitute or plug it in. And we actually did this towards the beginning of the year, and we were saying true or false. Is it a solution? Yes or no? So instead of having an x, we're going to put in a 7. So 2 times 7 plus 5, we get 19. Right now, can you do the same thing? Use your calculator if you need to. Plug in a -2, and then plug in a half, 0.5. So pause the video, go ahead and do that. So 2 times -2 is -4. Plus 5, we get 1. 2 times a half. What's half of 2? 1. 1 plus 5 gives us 6. Good job. We only had to plug in 3 numbers. But is there any limit to the numbers that we could plug in? No. There's no limit. Okay, there are infinitely many possibilities that we can plug in. You could choose your favorite number. You could choose your least favorite number. Positives, negatives, decimals, fractions, it doesn't matter. All right, question 6. Use the diagram to find input-output ordered pairs for the following values. So again, we have input-output function machine here, and inside the function, we see x squared plus 2x plus 3. Okay, so I'm going to take this -5, and I'm going to plug it in for both x's, here and there. So I'm going to write it out with you. -5, put it in parentheses, especially when you type it into your calculator, squared plus 2 times 5 plus 3. And we need to write them as ordered pairs, x, comma, y. Input, comma, output. So I'm going to start with a parenthesis. Oops. That's a -5 right there. Caught my mistake before I did the question. So my input is -5, comma, and whatever our answer is, we're going to write that as our output. So this becomes, you can type this into your calculator as one big question, right? Or this becomes 25, take away 10, plus 3. And we get 18. So I'm going to put an 18 as my output, and box it in because that's my answer. Question B, we're going to do the same thing. 3 divided by 5 squared plus 2 times 3 divided by 5 plus 3. Take some time plugging that into your calculator. Use parentheses calculator on your phone isn't sufficient, remember I put directions on how to download a calculator app on your phone, or you can use Desmos on your Chromebook. Desmos, D-S-M-O-S. I got calculators. I got 114 over 25, or the decimal of that is 4.56. Then let's do the same thing for negative 10. So negative 10 squared plus 2 times negative 10 plus 3. You're going to plug that in, and then we're going to write it as input, comma output. And I got 83. All right, let's do this again. Same type of question for number 7. We're going to make a function machine together. So let's draw an arrow, and these are going to be our x values, which are our inputs. And then I'm not a fancy drawer, so I'm just going to make a box. And inside my box, we're writing the expression 10 minus 5x. And then what comes out is our output, or our y values, also called our range. Okay, so we're going to use this function machine, and we need to find ordered pairs. And here are x values that we are plugging in. 3, negative 6, 0.25, and 3/4. So again, I want you to pause the video. I want you to use your calculator, or you can use Desmos, which is a calculator online. And I want you to plug in these x values. So x equals 3 would look like 10 minus 5. Instead of having an x, remember x comes out and sits on the bench, and 3 is the sub. 3 goes into the game. So plug that into your calculator, and you're going to write your answer as input 3, comma, output, which is your answer, or whatever your calculator tells you. Or you can do some of these in your head. When we plug in 3, we get negative 5. When I plugged in negative 6, I got 40. So these are my answers. This is the correct way to write it. 0.25, I got 8.75. Then when I plugged in 3/4, I got 25 over 4. You could change that to 6 1/4 if you wanted to. Some of you might have had the decimal form of that, which is 6.25. And this is where we're going to stop for today.